Okay, good morning, everyone. This question asks us in the question above. Shortly, we're going to solve this question. So, in the circuit above, the circuit above is in DC steady state. Find I and V. This is I, this current I, and then this voltage across this capacitor is V. And remember, the question said is in DC steady state. So, what happens in DC steady state is if you are making DC steady state analysis, you short out all the inductors. So inductors become short circuits. This inductor becomes a short circuit. Then capacitors become open circuit. So pay attention once again. What happens when you are dealing with DC analysis or DC steady state for RC circuit or RLC circuit? The capacitor becomes an open circuit. The inductor becomes a short circuit. So let's redraw the circuit. The DC model or this is steady state model. This is the model. So if you want to draw it, remember I'm starting from this top. So I'll redraw this circuit. I will have my resistor because resistor doesn't change. It's just the capacitor and the inductor that would change. So this capacitor becomes an open circuit, right? There was originally a capacitor here. Then I should have drawn an inductor, but because we are talking about DC steady state, it becomes a short circuit. So you place it with a wire, and then you have this current source here, this 6 ampere current source, 6 ampere. Then you have this 4 ohm resistor that's here, and then this 2 Henry capacitor, 2 Henry inductor you replace with a short circuit. And remember I'm here, so that's this place. You replace this with your voltage source. So voltage source still remains voltage source, current source still remain current source. The only thing that changes for DC steady state cases is just the capacitor and the inductor. There was an inductor here, there was an inductor here, there's a capacitor here. So that's what actually changes in this case. And remember, this is 2 ohms, this is 4 ohms, right? And then this is your current source, 6 ampere current source, and this 36 volt voltage source. So we are asked to find this current I here, and then plus minus the voltage V for this case. So this is quite a simple case. If you want to do this, remember I is a current passing like this, and if here is an open circuit, there is no longer current flowing here. So whatever current flows here will still continue up to this point. When they meet here, for a 6 ampere plus I that is coming this way would join, and then you have a current flowing here, and that current will be I plus 6 ampere, right? Because 6 ampere here, I here, so everything joins together to give you I plus 6 ampere. That will be the current into this 4 ohm resistor. And remember, we have to put polarity, positive, negative. If you still remember, positive, negative, how we normally assign polarities to our circuit. So quickly, let's solve this thing quickly. I'll write KVL across this loop, and then I'll be able to find I using that. So by KVL, by Kirchhoff's voltage law, I write KVL. I believe you all know how you write your KVL. So this very voltage source is going to be minus 36 because I'm moving in this direction. The first sign here is minus. Then this is going to be plus 2 times I because I have a plus sign here. Then remember, this is the loop I'm taking. Then there is no any element here up to this point. It's also going to be plus. The current is I plus 6 multiplied by the resistance is 4. Then I'm done with this. I'm moving still like this up to this point. That's where I will equate to 0. So this is a simple equation I can solve. This is minus 36 plus 2I, then plus, open this bracket, 4 times I, that's 4I, plus 4 times 6, that's 24. Everything gives you 0. So make I subject formula, 2I plus 4I, that will give you 6I. Take this minus 36 plus 24, that will give you minus 12, right? Equals to 0. So you make I subject formula, I becomes 12 divided by 6, which is equal to 2 ampere, right? So 2 ampere is the value of I. So if we've gotten the value of I to be 2 ampere, what else is the question asking us to find? We have to find I and V. So how do you find V? You just take KVL around just this small loop. This, not, our KVL was initially around the whole loop. So this small mesh here is what we'll take out by KVL again, by Kirchhoff's voltage law, around the small mesh. This small mesh, we have minus 36. That's this. Remember, we are just going like this. Minus 36, then plus 2i. That is 2 times this I. Then coming down here, you have plus V, because this voltage here, we don't know it. Let's say it's V, everything's equal to 0. I believe you all know why we have a minus, plus, and plus here. This minus, this plus, and this plus, right? So we'll make V subject formula. Remember, we've gotten our I already. That would be minus 36 plus 2 times, what is the value of I? 2, plus V equals 0. So minus 36 plus 4 plus V equals 0, right? So from here, we make our V subject formula. V becomes 36 minus 4. V equals 32 volts. So this is our final answer. I is equal to 2 ampere, and then V is equal to 32 volts. So that's our final answer. Thank you for watching. Have a nice day. So that's it for this question. I'll see you in the next video.